Now let us refresh our memory with memory initialization. So if you have an array, we could initialize our array structure or a memory with readmemh or readmemh. These are like hexadecimal or the binary version of it, correct? So what we are going to do, so we know in our memory model we had something like this. So, or let us go to the code itself. So this was our memory what we had. So this was like each location of mem data with wide, and then we had locations, like number of locations based on the address width, correct? So for a 5-bit of address we would have 32 locations. That is. So now because this logic variable defaults to an x, so on reset we had the default value of this all the locations as x, and if we had performed a read on a location before even writing to it, we would get a default value of x. But there are many ways to initialize the memory. We could do a loop to write it through all initialize through this. We could use a text file to do that as well. So for now, we are trying to approach it with respect to an initialization file. So if you see what we have done here is we have hit this plus button, and then we have created a new file. Our new file is named init_mem.txt. So this is the file what we have created. And if you see this has 32 locations because our mem address width was 5 bits, so it means there are 32 locations as such present in the in the memory. Now we could do it in multiple ways. We could even have a large structure and initialize only a portion of it. There are many ways to do that, but for this example we are trying to initialize all the locations of the memory. So and again this is we are trying to, and then if you see the data width was 8, so each 0 we are trying to say that this is a hexadecimal values, okay, this ff and 0, so whatever. So for 8 bits we need 2 digits, so that's the reason we have two digits. If it was a binary, then we would need all 8 bits to be listed here, correct? So that's the way it should be. So now when we have this, now this init mem.txt has to be applied to this mem for it to get initialized before the simulation starts, correct? So how do you do that? So we do it based on this. So from the top, if you see this is our test bench hierarchy within which we have instantiated our dot. Our dot is instantiated with the instance name i_mdl. So, and within the imdl our memory is present with the name of mem, correct? So from the top, if you see what is the hierarchy for this memory is imdl.mem. If you do, we can reach it to this hierarchy, correct? So having said that, now yeah, so now if you so in this case we have not this is the previous code. Even if we have added the memory, this is the we have running 100 transactions with the log disabled in this case. So this is the same thing, and it all passes, correct? Because this was the initial case what we had, in which we had 1000 transactions. We have added the text file, and then we know what is the hierarchy of this, but we have commented this block. This block is used to initialize the memory. So what we are doing, we have initial statements which gets triggered at the start of the simulation, and then we are trying to use a command or a function or task called readmemh with the value. The first argument is the text file or the file name, and second argument is the hierarchy where this file has to be applied. So what this will do, it will read all hex values one at a time from this file and apply to the respective locations on this particular memory, correct? So we have 32 locations and this has 32 entries. So on reset, this will get triggered, correct? This will initialize this memory to all zeros. Now with this enabled, let us just run this test case once. Wow. So now if you see we had 51 checks, out of 100 there was 51 reads, but now we have started to see failure messages, correct? Now the pass is 34, failure is 17, and then if you see now this log file, this is pretty interesting because this is the what we wanted to achieve all the way through, correct? Like when the log level is 0, we only wanted to print error messages. So these 17 error messages are actually these error messages which are listed above here, correct? So on address 1, the expected data was X and then actual data was 0. Oh, now this makes sense, correct? Because we are trying to initialize the memory with 0, correct? But in our test infrastructure, we had a like we were using a value for uninitialized memory of 80 XX, correct? So this is the one which causes failure, correct?